It is 18 after, so I'm going to go ahead and get started. No one has joined. What I'm going to be doing are some sample problems from the back of the book. And I'm going to skip the ones that I covered this morning. So here we go. Here's my share. And this one we did this morning. Problem number 4 from the back of the book we did this morning. Problem number 6 we did not do. It is similar to numbers 2 and 4. So I'll go ahead and do this one in case you're only looking at the afternoon Q&A and not the morning Q&A. So here you can see that first we have to write a balanced equation. 1 barium on this side, 1 barium on this side. So I'm going to add a no coefficients there. That looks good. One silver, 2 chlorines, 1 chlorine. So I'm going to have to put a 2 in front of there. And that looks pretty good. Except when I put a 2 in front of there, that changes the number of silvers. So I have to put a 2 there, and I have 2 nitrates and 2 nitrates. So it is now balanced. Now, what mass of silver nitrate in grams is required for complete reaction with 0.156 grams of barium chloride? What mass of silver chloride is produced? Now, for the balanced reaction, we have to understand that the coefficients of 1, 2, 2, and 1 are not grams. They are moles. So 1 mole of barium chloride is equal to 2 moles of silver nitrate if you were to react these in proportional manners, 1 mole and 2 mole. And 2 mole of silver chloride and 1 mole of barium nitrate. And you'll notice here that, oh, I forgot my mole there. There it is. As fitting, it's kind of underneath everything like moles are. So when we don't have a coefficient written, the coefficient is 1. So that means that if I had 2 moles of barium chloride, I would need 4 moles of silver nitrate. Or I could say if I started with 2 moles of barium chloride, I could potentially make, if I start with 2 here, 4 moles of silver chloride, and so forth and so on. So here, they want to know what mass of silver nitrate in grams what mass of silver nitrate in grams can be made by reaction of 0.156 grams of barium chloride? Well, you know, if these coefficients were gram and gram, I could do this, but they're not. These coefficients are moles. So I can go from moles of barium chloride to moles of silver nitrate. All I need is a balanced reaction, which I have. So the question then is, can I go from grams of barium chloride to moles of barium chloride? And can I go from moles of silver nitrate to grams of silver nitrate? And the answer is absolutely. Here, I need the molar mass of barium chloride. Here, I need the molar mass of silver nitrate. And I'm going to calculate these very quickly. So for silver nitrate, silver is 107.87. Make sure I get that right. Yep. Nitrogen is 14.01, and 3 oxygens is 48. So this is 169.88 grams. And for barium chloride, a barium is 133 or 137.33. add to that 2 chlorines, which would be 35.45 plus 35.45. So this comes out to be 208.23 grams. And here we just need the balanced reaction. And really the coefficients from the balanced reaction. So to calculate the grams of silver nitrate, we would start with 0.156 grams of barium chloride. And this is conversion 1. This is conversion 2. This is conversion 3. And I would multiply by 208.23 grams of barium chloride, and that would go on the bottom. And of course, that goes on the bottom so that these cancel. And then I'd put 1 mole of barium chloride on top. Then I would multiply by the fact that we have 2 moles of silver nitrate to 1 mole of barium chloride. Now notice the moles of barium chloride go on the bottom, and I get these numbers 1 and 2 from the balanced reaction. And then finally, you multiply by 169.88 grams of silver nitrate per 1 mole of silver nitrate. And this is okay. This is exactly what we prefer. You might say, well, in this balanced reaction, there's 2 mole of silver nitrate. And yeah, there is. There's 2 mole of silver nitrate. But then the molar mass of 2 moles of silver nitrate would be 2 times 169.88 grams of silver nitrate, which begs the question, why put the 2's there? Why not just do 1 mole is that many grams? So you don't want to do this. All right, we can estimate the answer. 2 times 170 is 340. 340 over 20, well, maybe hard to do, but we could consider that to be 34 over 21, which is like 7 over 3. No, 5 over 3. So 5 over 3 is a little less than twice this number. Twice this number would be 0.31 or something. So we'll say the answer is around 0.3 or 0.29. Okay, so 0.156 times 2 times 169.88 divided by 208.23, and we get 0.255 grams of silver nitrate. And for a problem like this, this is what I would expect to see as the answer. You would not break it up into 3 problems. It would just be 1 problem with 3 conversion factors. This would be the correct number . So you can see we get 0.255 grams. You certainly have to write less, but this is not nearly as good as what's above because we don't know what we're starting with and we don't know what we're ending with. We just know how much we're starting with and how much we're ending with. And we have no reason for going through this conversion and saying that 0.156 grams is equal to 0.255 grams when they're not. Okay. So if you wrote an answer out like this, would you get some credit? Yeah. Would you get full credit? No. Would you get passing credit? Nope. Okay. So you really want to have these labels in here. And that's how you do that problem. So here, what mass of silver chloride is produced based on the same idea? So let's take a look at this. Oh, I actually did that. What mass of silver chloride? No, I did that. I did silver nitrate. What mass of silver chloride is produced? Well, let's do that one next. So remember, for our balanced reaction, we have barium chloride 2 silver nitrate, 2 silver chloride, and 1 barium nitrate. So there's our balanced reaction. And the question mark is, how many grams of silver chloride this time? Starting with 0.156 grams of barium chloride. So we cannot go directly from grams to grams. However, we can go from grams of barium chloride to moles of barium chloride. And then we can go from moles of barium chloride to moles of silver chloride. And then moles of silver chloride to grams of silver chloride. Now, the molar mass of this is 208.23 grams. And the molar mass of silver chloride is going to be 107.87 plus 35.45. So here we get 143.32. And let's now fill in the rest. So my first conversion, I'm going to use this 208. That's going to go on the bottom because that's 208 grams, 208.23 grams of barium chloride to 1 mole of barium chloride. And then next, we got to go from moles of barium chloride to moles of silver chloride. And it looks like I have 1 mole of barium chloride. And I have 2 moles of silver chloride. And then we have, finally, 143.32 grams of silver chloride to 1 mole of silver chloride. So I'm going to estimate my answer. Here I have 14 over 21, essentially. If I round these off a little bit. So if I have 14 over 21, that's the same as what? 2 over 3. So if that's 2 over 3, then I have 4 times 2 is 4 over 3. So 4/3 of this, which means take 1/3 of this and add it to it. So I should get around 0.2. So let's see what we get. 0.156 times 2 times 143.32 divided by 208.23. And I get 0.215 grams of silver chloride. And so that's the answer we would get. So we get 0.215 grams of silver chloride, starting with 0.156 grams of barium chloride. Here, we need to have 0.255 grams of silver nitrate. So my question now is, how many grams of barium nitrate would be produced? And there are 2 ways we can get this. We could start with 0.156 grams of barium chloride, convert that to moles of barium chloride, convert that to moles of barium nitrate this time, and then 2 grams of barium nitrate. What we do need is the molar mass of barium nitrate. So the molar mass of barium nitrate is 137.33 plus 2 nitrogens, which is 28.02, plus 6 oxygens, which would be, let's see, 3 of them is 48, so 6 is 96. So I didn't do that right. 137.33 plus 28.02 and then plus 96. I'm not using my calculator right. So 137.33 plus 96 makes it almost 237. And then plus 28.02 is going to make it, what is that? 261. Okay, so we would start off with 0.156 grams of barium chloride times 208.23 grams of barium chloride per 1 mole of barium chloride times 2 mole of silver. Oh, we're doing for barium nitrate. 1 mole of barium nitrate to 1 mole of barium chloride, and then 261.35 grams of barium nitrate to 1 mole of barium nitrate. So if we multiply all of this out, you can see that 261 over 208 is like a 1.2 or 1.3. It's a little bit more than 1. So we multiply that by that, and this should be a little bit more than 1.56. So maybe it's, I don't know, 1.8. Let's find out. 0.156 times 261.35 divided by 208.23, and we get 0.196 grams of barium nitrate. That should be a 2 there. So there would be the work. Now, what's another way to do it? Well, the other way to do it is we realize that 0.156 grams of barium chloride plus 0.255 grams of silver nitrate should equal 0.215 grams of silver chloride plus whatever many grams of barium nitrate we would need. So how do we figure that out? Well, we add these two numbers together, 0.156 and 0.255, and we got 0.4-ish minus that, and we should get about 0.2. And we get that this is equal to 0.196 grams of our barium nitrate, which, if you notice, is the same number as we got here. Okay. So that's similar to the first two problems from the chapter, or the first two even numbered problems. And now I'm going to put this one aside. Now, this is one that you can look up in the previous lecture or Q&A. This one is actually far simpler than what we've been doing. So we are starting with 6.2 mole of iron 3 oxide, and the question mark is how many moles of carbon? Now, can we go directly from moles to moles? And the answer is absolutely, with this balanced reaction. So 6.2 moles of iron 3 oxide times 3 mole of carbon and 2 mole of iron 3 oxide. And we're going to get 2 will go into that 3.1 times. 3.1 times that is 9.3. So we get 9.3 mole of carbon. So that's how you would do carbon. How would you do iron? And how would you do carbon dioxide? Well, I'll let you work with those. Okay, let's take a look at another one here. Now, this one is called a combustion reaction. I bet you there's another combustion reaction in here. Let me see. Ah, yep, here's another. Well, no, that's not a combustion reaction. Ah, here's another combustion reaction. So we'll hold off on this one till later. This one was actually done in the morning. So if you want to see this one done, you should look at the morning lecture and kind of fast forward until you get to number 10. This one we also did in the morning. This is called a limiting reactant problem. I'm going to put that one off to the side because you can look at the morning Q&A and see that one. And instead, for the afternoon Q&A, I'll do a similar problem where we have a limiting reactant problem. So what do we mean by a limiting reactant problem? I'm going to give you the same explanation I gave this morning. So this morning, the explanation I gave had to do with a bicycle. So here's the beginning of a bicycle. Here's the fork, handlebar, seat. And with this bicycle, you need two wheels to make a bicycle. So this is stoichiometry, 1 to 2. And when you're done making this bicycle, so here's the frame again, and we put the wheels on the bicycle. So one of the wheels is centered on that little triangle, and the other wheel is centered on the fork. So you have your bicycle. So imagine that we have two bicycle frames and we have excess wheels, meaning we have as many wheels as we need, more than enough. How many bikes can we make? We can make 2. Now imagine that we had excess frames, but we had 10 wheels. How many bikes could we make? Well, we could only make 5. We could only make 5 because we'd run out of wheels after that. Well, what if you had 2 frames and 10 wheels? How many bikes could you make? And the answer is, well, we'd run out of frames after 2 frames, even though we could make 5 with 10 wheels, but we've run out of frames. So the answer is 2. So here in this case, because this tells us how many we can make, it's called the limiting reactant. And this one is in excess. So another way to figure out which one is limiting and which one is excess, we could say 2 frames times 2 wheels per 1 frame. Where do I get the 2 wheels in 1 frame? Right here, 2 wheels, 1 frame. And we get 4 wheels. So what does this 4 wheels mean? It means we need 4 wheels to use 2 frames. So what do we do with this number? We look at this 4 and we compare it to the 10. Do we have enough wheels to react with both frames? Absolutely. So that means both frames are used up. Will we have leftover wheels? Well, if we only use 4 and we have 10, we will have leftover wheels. So this tells us that the wheels are in excess. Why? Because we need 4, but we have 10. And the frames are limiting. Why? Because the frames are used up. The frames are used up, and they really tell us how many bicycles we're going to make. All right, so that's the idea of a limiting reactant. And you'll notice that I solved the problem 2 ways as far as finding out what was limiting and what was in excess. First, I just did this. I asked myself, how much product will this one make? How much product will this one make? The less amount of product is how much product I'm going to make. I'm not going to be able to make 5 bikes when I have 2 and 10. Okay? So you go with a lower number. So here, what if the question was, how many bikes are you going to make? Well, we've already answered that here. How do we do that down here? Well, we take our 2 frames times 1 or 2 bikes. Actually, 1 bike per 1 frame, because that's what it says up here, and we get 2 bikes. So that's how many bikes we could make. All right, so let's put that into practice with this problem right here. We're going to do this 2 ways. And our first way is going to be, well, we'll see. So disulfur dichloride is used to vulcanize rubber. It can be made by treating molten disulfur, or excuse me, sulfur with gaseous chlorine. So here's the reaction. Turns out that sulfur is a weird molecule. It can actually come in 8 atoms. So here we have sulfur. This is a liquid. It's molten, which means you have to heat it up. In this case, reacts with 4 gaseous molecules of chlorine to give you 4 of these disulfur dichloride. Starting with a mixture of 32 grams of sulfur and 71.0 grams of chlorine, which is the limiting reactant. So let's take a look at the limiting reactant. 2 ways. So I'm going to start with 32 grams of sulfur, and I'm going to find out how many grams of chlorine I need. So if I start with 32 grams of sulfur, and here we can go ahead and start with 32 grams of S8 times 1 mole of S8. And since there's 8 sulfurs, I have to multiply 32.07, that's the molar mass of sulfur, times 8. So I get 256.6 grams of S8. And then I need to use the coefficients. So times 4 mole of chlorine per 1 mole of S8. And then chlorine is 70.90 per 1 mole of Cl2. So how many grams of Cl2 do we get? We can estimate the answer. 70 goes into 256 about 3.5 times. 4 divided by 3.5 is close to 1, but not quite. So when I multiply that by 32, maybe I get 36. So maybe I get 36 grams here. Let's find out. 32 times 4 times 70.90 and divided by 256.6, and I get 34.1 or 2. Okay, so this means if we use 32.0 grams of sulfur, we need 34.2 grams of chlorine. Okay, and that's a perfect match made in heaven. However, if we take a look, we have 71 grams of chlorine. We have 71.0 grams of chlorine. So if we only use 34, there's going to be leftover chlorine. And in fact, we're going to say what? Chlorine is in excess. So that means that the sulfur is limiting because it's used up. Okay, so we found out that the chlorine is in excess and the sulfur is limiting. So we've answered A. Now B, what is the theoretical yield of this disulfur dichloride? Well, to do this, we're going to have to say 32.0 grams of S8. We're going to convert that to moles of S8, convert that to moles of S2Cl2, and convert that to grams of S2Cl2 to calculate the actual yield based on the limiting reactant. So the yield is going to be based on the limiting. So we're going to have 32.0 grams of S8 times 1 mole of S8 over 256.6 grams of S8 times, according to our balanced reaction, 4 mole of S2Cl2 disulfur dichloride over 1 mole of S8, 1 mole of S8. And then for disulfur dichloride, we have 32.07 times 2. And then we have to add our 70.90. And we get 135.04 grams of S2Cl2 per 1 mole of S2Cl2. So when we estimate this, I would venture that this goes into this about 2 times. 2 goes into 4 about 2 times. So 2 times 32 means I should get about 64 grams of S2Cl2 or disulfur dichloride. So 32 times 4 times 135.04 divided by 256.6 is equal to 67.4 grams of S2Cl2. So that's the answer to B. And for C, it says, what mass of the excess reactant remains when the reaction is complete? What mass of the excess reactant is left over? So here, we know that we use 34.2 grams of Cl2. We have 31.0 grams of Cl2. So what's going to be left over? The leftover is going to be the 71.0 grams minus the 34.2 grams, which is going to be roughly 35 grams, right? So we get 36.8 grams left over. Okay, so that's one way to do this problem. Let's try another way. So here, we're going to do A and B simultaneously. So I'm going to start with 32 grams of S8, convert that to moles of S8, convert that to moles of S2Cl2, and convert that to grams of S2Cl2. And then I'll do the same with 71. I'll get the grams of S2Cl2. Compare those two numbers. The smaller of the two numbers is how much we make. So that would be the answer to B. So 32.0 grams of S8 times 1 mole of S8 per 256.6 grams of S8. I believe that's right. Yep. Times 2 mole of S2Cl2 per 1 mole of S8. And wrong number, 4 moles. There it is, 4 and 1. And then times, what is it, 135.04 grams of S2Cl2 per 1 mole of S2Cl2. And let's see what we get here. 32 times 4 times 135.04 and divided by the 256.6. And we get 67.4 grams of S2Cl2. Now, if we start with 71.0 grams of Cl2, we're going to convert that to moles of Cl2. There's 1 mole of Cl2 per 70.90 grams of Cl2. We're going to convert that to moles of disulfur dichloride. And then we're going to convert that to grams of disulfur dichloride. So when we multiply all of this out, you can see that this roughly goes into that 2 times. 2 times that is going to be roughly 140. And we get 135 grams of S2Cl2. So the answer to B is 67.4 grams of S2Cl2 because it's the least. We're going to use that 32 grams up and make 67 grams of this. We can't make any more of this because we've run out of that. So we can't make 135 grams. So that's why you pick the lesser of the two. Okay. And in this particular problem, if we want to do C, how much is left over, we can do this. We're going to use 32.0 grams of this. Here, we want to know how many grams we would use of that. And here, we know that we're going to make now 67.4 grams. So remember, in C, we're supposed to figure out how much leftover chlorine we have. Well, we use 67.4 grams minus 32.0 grams of chlorine, because these two numbers should equal that, and that's the amount of chlorine we've used. So I get 35.4 grams used. And so left over, we have 71.0 grams minus 35.4 grams, which ends up being 36.6 grams. Or is it 35.6? Let's see, 71 minus 35.4. And we got 35.6 grams left over. There you go. So if you take a look at the amount of work we had to do this way, compare the amount of work we had to do this way, it's pretty similar, and they both give you the same results. Okay, so that's number 14. Now, that's pretty much what we covered this morning. And I didn't do 16 or 17 or any of these others. I'm going to leave it at that for today. Kind of a short lesson, but if you watch the morning Q&A and the afternoon Q&A, you'll get a lot of practice with this idea of how to convert from grams of one thing to grams of another. All right, well, thank you for watching this. Bye-bye.